Good evening, everyone. Tonight we are going to look at 2-6, multiplying and dividing with scientific notation. To multiply values in scientific notation, we're going to rearrange the multiplication problem and apply the laws of exponents. So looking at this first example, I'm going to group the two first numbers together. So I'm going to have 4.5 times 2. And then I'm going to group the bases of 10 together in the next grouping of parentheses. So that's going to be 10 to the 5th power times 10 to the 3rd power. Let's go back to your 7th grade math class. Do you remember what two properties those were that you used to be able to move those around? I'm certain that you do. That would be the commutative property and the associative property. So you're moving some things around and then you're regrouping them. Okay, so we can go ahead and do what's in the first parentheses, 4.5 times 2, that gives us 9. And in the second parentheses, the bases are the same, so we will add the exponents. So that's going to be times 10 to the 8th power. Okay, we're going to do the same thing with the regrouping to divide in scientific notation. So I'm going to group the 8 and the 4 together, so 8 divided by 4, and then 10 to the 6th power divided by 10 to the 3rd power. Okay, 8 divided by 4 is 2, times 10 to the 6th power over 10 to the 3rd. Hopefully you remember that the rules of exponents, when the bases are the same, we subtract those exponents, so that's going to be 10 to the 3rd power. Okay. All right, now we're going to look at the 4 at the bottom. I'm actually going to save number 1 for last because there's something extra special that we have to do to it, and I'd rather make sure you're a little more comfortable before we get to the hard one first. Okay, so we're going to regroup on number 2. I'm going to put the 1.5 times 5 together, and I'm going to put the 10 to the 5th power times 10 to the 3rd power together. I have to write this 1.5 times 5 over to the side and multiply this way. 5 times 5 is 25. 5 times 1, 5, 6, 7. I get 75. I have one place after the decimal, so I'll have one number after the decimal there. So in scientific notation, I have 7.5. When I look at this right here, add my exponents together, that'll be times 10 to the 8th power. Now, to put it in standard form, I need to move that decimal 8 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8 gives me 750 million. Okay. All right, let's take a look at number 3. We're going to regroup that 9 and the 3 and the 10 to the 9th power and 10 to the 7th power. Well, 9 divided by 3 is 3. And 10 to the 9th divided by 10 to the 7th. Again, remember we're subtracting those exponents. That will give me 10 to the 2nd power. Okay. And in standard notation, just let me go ahead and put this little thing out here. To put it in scientific notation, if we moved the decimal to the left, we would have 10 to a positive power. So what we have to do now is we kind of have to do the reverse of that. We're going to try to get it back into standard form. So we're going to move the decimal to the right that many times. So if I move the decimal to the right 2 times, it'll be 300 as my answer. Okay. Let's divide this number 4. Okay, so 9.45 divided by 21, or I'm sorry, 2.1. Well, I'm going to move the decimal over 1 to make it 21, and if I do that on the outside, I have to do that on the inside. So 21 goes into 94. I'm estimating 4 times. Okay, so 4 times 1 is 4, and 4 times 2 is 8. That was a good guess. Subtract that, that will give me 10, and I'm going to bring down that 5. Okay, so how many times would 21 go into 105? 5 times. And 5 times 1 is 5, and 5 times 2 is 10, so perfect. Okay, so in scientific notation, at least the first part is 4.5. 10 to the 7th divided by 10 to the 2nd, we'll subtract those, and that'll be 10 to the 5th power. So again, remember, we're going to move that decimal to the right 5 times. So 1, 2, 3, 4, 5. That'll give me 450,000. Okay, I'm going to go back up to number 1, the one that I said was a little bit difficult. Let me show you why I saved it for last on this page. Okay, we're still going to multiply the first numbers. So I'm going to have 7.2 times 3. And I'll get 6, 21. Okay, so do you see what the problem is yet? What I have is I have 21.6. When I add the exponents here, I'll have times 10 to the 6th power. Okay, what's the problem is this number right here is not between 1 and 10. I need to get it in between 1 and 10. So in order to do that, let me put that little notation up here again. Okay, I need to move my decimal between the 2 and the 1. So this is 2.16, and since I moved it to the left, it's going to be to the first 10 to the positive first power. Then I'm going to bring this down right here. Do you see that 2.16 times 10 to the first power is equivalent to 21.6? Okay, so I haven't changed the math. I've just added, I've moved the decimal and then added the power of 10 there. So now I can bring this down, 2.16, and I can add those exponents together. That'll be 10 to the 7th power. Okay, in standard form, I need to move that decimal over 7 places. 1, 2, 3, 4, 5, 6, 7. Go back and put my commas in, and that's 21 million. Okay, we're going to see a few more of those. I hope that makes sense. That was a little bit tricky, and I don't like that they put that as number 1. All right, let's go to the back side, see if we can find any more of those. Okay, on the back side, we're doing the same thing, except they have some that are in standard form, they have some that are in scientific notation, and we need to get them all in scientific notation. So again, if I move it to the decimal to the right, it's going to be to the negative power that many times. If I move it to the left, it's going to be to the positive power that many times. So I need my decimal point to be here. I'm going to move it to the right 1, 2, 3, 4, 5 times. So 1.2 times 10 to the negative 5th power, 6 times 10 to the negative 2nd power. Okay, so when I multiply those, 1.2 times 6, that is going to give me 6 times 2 is 12, 6, 7, that is going to give me 7.2. Okay, so I'm going to group the first numbers together, group the base of 10 together, and I can just put that in scientific notation. That is 7.2 times 10 to the negative 7, because negative 5 plus a negative 2 is a negative 7. Now in standard notation, remember I'm going the opposite direction. So it's already at the negative side. I need to go back to standard form. So I'm going to be moving the decimal to the left 7 times. So what I usually do is I just put that there. I know that decimal is between the 7 and 2, so the 7 is 1, 2, 3, 4, 5, 6, 7. Okay. All right, so there should be a total of 6 zeros there. All right. Let's take a look at number 6. Okay, I need to put this one over here in standard or scientific notation, so I'm going to move the decimal over 1, 2, 3, and if I move it over 3 times to the right, I know that's going to be to a negative power. So I'm going to have 4 times 10 to the negative third power, 7.3 times 10 to the negative 1. Okay, I'm going to go ahead and regroup. Okay, and let's do the multiplication. 7.3 times 4. 4 times 3 is 12, carry the 1. 7 times 4 is 28, plus 1 is 29. And put my decimal in there, and look, we've got another problem. Okay, so I've got 29.2 times 10 to the negative fourth power, because negative 1 plus a negative 3 is negative fourth. Do you see what the problem is? Okay, this is not in scientific notation. If I move, and I keep wanting to put this up here so I can see which direction to go pretty easily. I've got to move the decimal to the left one time. So if I move it to the left, that's going to make it to the positive first power. So I'm going to rewrite what's in the box as 2.92 times 10 to the first power, and then I'm going to bring down the times 10 to the negative fourth power. Okay, so I have 10 to the first power times 10 to the negative fourth power. So 1 plus a negative 4 is a negative 3. So this is 2.92 times 10 to the negative 3. Okay, going back into standard form, it was on the negative side, so I need to move the decimal to the left 3 times. So the 2 counts for 1, 2, 3, right there. So there should be 2 zeros in front of it. All right. Number 7, let's go ahead and do that as well. Get that denominator into scientific notation. I'm going to be moving the decimal over 1, 2, 3, 4, 5 places to the right. So that would be a negative 5. All right. 6 divided by 3, that's the easy part. That's going to give me 2. And then here, be careful with your rules of signs. That is 10 to the negative 3 minus a negative 5. Okay, so don't forget that. Keep, change, change. So that becomes negative 3 plus 5. Okay, so that would be 10 to the second power. Okay, and in standard form, that would be 200. Okay, number 8, this time we need to put the numerator in scientific notation, so we're going to move that decimal over 1, 2, 3, 4 to the right. So 9.6 times 10 to the negative 4, since we moved it to the right, over 1.2 times 10 to the negative 8. Okay, so let's do this first. I'm going to have to do my work over here. 9.6 divided by 1.2. Move that over 1, move that over 1. And that was my husband. Sorry about that. And 12 goes into 96 8 times. 8 times 12 is 96, so that one worked out perfectly. Okay. So that's going to give me 8. All right, now as far as this goes, be careful. We've got negative 4 minus a negative 8. So keep, change, change. Okay, and negative 4 plus 8 would be 10 to the fourth power. Okay, all right. Now we have to move the decimal over to the right 4 times. 1, 2, 3, 4. So our answer is 80,000. All right, getting close. Of course, we have some word problems here. We have to figure out if we are supposed to add, subtract, multiply, or divide. Well, since the lesson is on multiplying and dividing, we've got it down to 2. We have a top NBA player that is earning 2.5 times 10 to the 7th power dollars each year. Poor little John, he only earns $40,000 per year. How many times greater is the NBA player's salary? Okay, so we need to find out how much greater it is. So the way to do that, we are going to have to divide. We've got the NBA's salary, and we've got the college student salary. Let's go ahead and put John's salary in scientific notation. So I'm going to move that decimal 1, 2, 3, 4 to the right. Okay, and let's go from there. Four goes into 2 0 times, but it goes into 25 6 times. 4 goes into 10 2 times. Oops, I'm going to have to do some erasing. Okay, that gives me an 8. And 4 goes into 25 times. Finally, it works out. Okay, so I have 0.625, and I already see a problem. Okay, and I'm going to bring down the 10 to the 7th over 10 to the 4th. I'm going to subtract those exponents. That will give me 10 to the 3rd power. Okay, I've got to get this in scientific notation, so I'm going to move the decimal to the right once. So that would be 6.25. Since I moved it to the right once, that'll be to the negative 1st power. Then I'm going to bring that down times 10 to the 3rd power. So in scientific notation, that stays there. And let's see, negative 1 plus 3, that's going to give me 10 to the 2nd power. All right, so when I multiply it by 10 to the 2nd power, I'm going to move that decimal over 2 places, and it'll give me 625. So the college player, actually the NBA player, makes 625 times the amount of money that poor John makes. But I'm sure John is a happier, more well-rounded person. Okay, and the last one, number 10. If Kelly's heart beats an average of 1 times 10 to the 2nd power times per minute, how many times does her heart beat in a year? They give us a hint that 1 year is 525,600 minutes. All right, so let's convert that to scientific notation. So that would be 5.256 times 10 to the, let's see, we move that decimal over 1, 2, 3, 5 times. 10 to the 5th power. Okay, so I know that it beats this much in 1 minute, so we need to find out how many times it beats in 525,600 minutes. So we're going to multiply those. Okay. Do it like this. Okay, so I'm going to multiply the first numbers, and fortunately anything times 1 is itself, and that is between 1 and 10, so I can leave that there, and multiply these by adding the exponents. And then now I'm going to move the decimal place 7 to the right. So the 2 is 1, 2, 3, 4, 5, 6, 7 places. Okay, so 52,560,000 beats in a year. Okay, hopefully that helped you. Good luck on the prep work. Look out for those answers that are not in scientific notation. Make sure you're good with the conversions.